You can see that the counter is working fine. See, it's 0 to 999 counter, 999. You can see that it is working very smoothly and very fine. You can see that it reaches 999 and then it starts all over again. See that? Now again it will reach the 999 value, then it will start over again from the 0. See that it has reached the value, then it goes back and starts over again. This technique is called the multiplexing technique of displaying the value on the 7 segment. One by one each digit is being updated, but at such a high speed that our eye gets confused. It thinks that it's constantly on, but in reality at a very high speed it is triggering taking place. One by one each digit is updated. Hello guys, welcome to learning microcontrollers. In this video I'm going to show you how you can interface a 4-digit 7-segment cathode type display with a PIC16F877A microcontroller to run a counter from 0 to 999. So let's get started. So guys, this is our 4-digit 7-segment display that we are going to use here. It's a cathode type. As you can see, it has 6 pins at this side. It also has 6 pins at the other side as well. So guys, this is our 4-digit 7-segment display cathode type from the top view. Now as you can see that at the top back side you have 6 pins here, and now at the top bottom side you have, at the bottom back side you have 6 pins here if you hold it like this. Now at the top back left side, the leftmost pin is the D1 pin, that is the digit 1. Then we have A pin, F pin, digit 3, digit 2 and the segment B pin. Then at the bottom left we have E pin, D pin, dot pin, C pin, G pin and the digit 4 pin. Now guys, this pin, that is the digit 1 pin, correspond to this digit, and in case of a 7-segment cathode type, whenever you will give this, you will connect this digit 1 pin with either the ground or you will send a 0 from the microcontroller to this pin, this digit will get enabled. In case of an anode, it's opposite. You have to connect it with either the 5 volt or send a 1 from the microcontroller. But in our case, we are using a 7-segment cathode, so we will need to send a 0 to this pin from the microcontroller to enable this digit. Now similarly, this digit 2 pin, D2 pin correspond to D2, and this is the digit 3 pin and this is the digit 4 pin. So total there are 12 pins in this module. 8 are for the 7-segment LEDs including the dot, and rest of the 4 are for the 4 digit enable pins. So total there are 12 pins. So let's get started. So this is guys our PIC16F877A microcontroller having 40 pins. It's a DIP version. And this is the 4-digit 7-segment display as shown in the previous slide. I'm again gonna label it for you like this. At the top back left side you have digit 1 pin, then A pin, then F, then digit 2, digit 3 and B pin. Now at the bottom left you have E, D, dot, C, G and the digit 4 pin like this. Now guys, this digit 1 pin correspond to this digit. This is the digit 1, digit 2, digit 3, digit 4. Now guys, to connect it with a PIC, you will need 8 to 20 ohm resistors. You can use a 100 ohm to 330 ohm value, but the best preferable is the 220 ohm resistor. So first of all, for the A pin, connect it to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, send it to the pin number B0. I'm going to use a port B for this. You can use any port having 8 pins. So port B has 8 pins, port C has 8 pins, port D has 8 pins. You can use any of these 3 ports in the PIC16F877A. If you have other PIC microcontroller, then remember that whichever port you use, that must have at least 8 pins. Else you will not be able to use the 7-segment editor tool of the MikroC. Rest will be fine. Then you have to send digits manually. So guys, now for the B pin, connected to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, send it to the pin number B1. Now for the C pin, connected to the one end of the 220 ohm resistor like this. Now from the other end of the 220 ohm resistor, send it to the pin number B2 like this. Now guys, for the D pin, connected to the one end of the 220 ohm resistor like this. Now from the other end of the 220 ohm resistor, send it to the pin number B3 like this. Now guys, for the E pin, connected to the one end of the 220 ohm resistor like this. Now from the other end of the 220 ohm resistor, send it to the pin number B4. Now guys, for the F pin, connected to the one end of the 220 ohm resistor like this. Now from the other end of the 220 ohm resistor, send it to the pin number B5. Now guys, for the G pin, connected to the one end of the 220 ohm resistor like this. Now from the other end of the 220 ohm resistor, send it to the pin number B6 like this. Now finally for the dot pin, connected to the one end of the 220 ohm resistor. Now from the other end of the 220 ohm resistor, send it to the pin number B7 like this. In this way our 7 segment is connected. Now we come to our digit pins. We have 4 digit pins. Now since we are using 3 digits, that is 999 will be the max value. So we will only need the 3 digit. The 4 digit will go empty. Why we are using basically 3 digits, 4 digit display? Because it is easily available at my place. If you can buy a 3 digit 7 segment display at your place, then go for it. But at my place 4 digit is available, 3 digit was not available, so I am going to use a 4 digit. So here this will be our unit digit. D4 is a unit digit, D3 is a 10th digit, and D2 is a 100th digit. Now so we will discard the D1. We will only use D2, D3 and D4, that's all. Now first of all I will connect the D2. For the digit pin you do not need a resistor. You can connect it to any available digital input output pin. For the D2 I am going to use a pin number D1, that is pin number 20 of the PIC16F877A. For the D3 I am going to use a pin number 21 of the PIC, that is D2 pin. Now for the digit 4 I am going to use a pin number 22 of the PIC16F877A, that is the D3 pin. In this way our digit pins are connected as well. Now guys, this is our unit digit. D3 is the 10th digit, D2 is the 100th digit like this. So before we continue, let me first introduce you to the hardware. Guys, this is the hardware we have here. This is the 4 digit 7 segment display. Because the brightness is too much, a camera is not able to catch the lights falling on it. So I am going to use this a translucent plastic case to lower down the you can say the brightness. Then this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is PIC at 3.5 burner. Now let's get to the MikroC for PIC programming tool. MikroC for PIC programming software we are going to use here. It's version 7.2.0. You can update to the latest versions as well, so that will be better. So right now click on file, new project. This pops up, new project wizard. Click on next, write the name of the project. I write 0 2 9 9 9 9 4 times 9 7 segment tutorial learning microcontrollers. So this is the name of the project I wrote, and PIC16F877A is the one I am using, and 20 MHz is the crystal I am using. I click on next and finish. So guys, this window will pop up. Before doing anything else, save your project, press Ctrl S. So save your project, the project is saved. Now guys, the next thing is, first of all, you have to initialize the 7 segment port, that is the port B. Write down port B equals to tris B. First we have to initialize the port. Tris B equals to 0 cross 0 0. And now the initial state, all the LEDs by default must be off. So port B equals to 0 cross 0 0. Like in case of an Arduino, it is like pin mode command, and this is a digital write command. Initially all the LEDs must be off. Now give some initialization delay. 20 will do fine. Now the next thing is we initialize the digit pins. Now for the digit pins, write down tris D. We are having digit pin at port D equals to 0B 1 2 3 4 5 6 7 8. Now this is a binary way of sending a declaration to the pins. Now this 0 represents the D0 pin of the PIC, port D, D1, D2, D3, D4, D5 and up to D7. So it's like 1 2 3 4 5 6 7 8. 8 zeros means 8 pins of the port D. So we have our 7 segment at D1 pin, D2 pin and D3 pin. So we have digit 4 3 2 at the digit D3, D2 and D1 pins like this, while this is empty, not connected. So guys, in this way, why we are declaring them 1? We should give them 0. Oh, okay, this is fine. Now we have our 8 digits initialized in the binary form. Now let's give it the initial state. Initially 0B, we simply copy it like this. Now remember that what I told you when we are using a common cathode. In case of a common cathode, we have to send a 0 to enable the digits. So these digits by default must be 0. So this is for the initialization, that all the digit pins are basically output pins like this. and output is sent from the PIC. So we declared all the pins output. Now we are giving it the initial state. Initially, the digit pins must be at 1 because in case of cathode, 1 means disable. 1 means the digit is disabled, and by default the digits must be off. So we had disabled the digits. It's port D. So at port D, the digits by default, that is the D1, D2 and D3 pin holding D2, D3 and D4 digit, are now off. So now here we got our 7 segment initialized. This is where we got our digits initialized. Now we can go for the programming. But first of all, for the 7 segments, we will need an array of integers which will hold the data. So we have 0 to 9 digits in mathematics maximum. So we have to display them on the 7 segment. For that, we initialize an array of 10 digits. 10 digits mean 0 to 9 is basically a 10 digit in case of programming. So first of all, go to this tools, select this 7 segment editor. Now here, this pops up. Let me zoom out because it do not work when you are zoomed in. Make a 0 on the screen. When you make a 0 on the screen, you will see that you will get 63 common cathode decimal value. You copy this and paste it in this array. So this means that now display 0 means 63 is to be displayed on the screen. So port B equals to display 0. It will mean that a 0 is displayed on the 7th segment. In this way, you will make the next character, declare a complete array of 0 to 9, make a 1 here like this. Now this is a 1. For 1, it's a common cathode value of 48. Paste it here like this. So now guys, this is why I told you that you must make sure that, let me show you again. You have to make sure that 0 is connected to A, 1 is connected to B, 2 is C, 3 is D, and so on. You may use the other port. B might be D or C, but 0 is for A, 1 is for B, 2 is for C, etc. You have to follow this sequence, else you will not be able to use this helpful tool. Then you have to send this manually. Now for the 0, 1, 2, now make a 2 here. We have to initialize a complete array. Now this will be a 2. So for the 2 we have 91. Copy paste it. Now make a 3. For the 3 we have 79. Copy paste it here. Now for the 4 we have 110. Oh sorry, 102 for the 4. Now make a 5. For the 5 we have 109. Copy it, paste it here. Now for the 6 we have 125. Now for the 7 we have 39. Now for the 8, all the LEDs will be on. Turn on all the 7 segments like this. This is the 8. Now for the 9 we have this, just turn it off, it will become a 9. Now 111 is for the 9. Now in this way we got our all the digits initialized. Now it's display 0, it means 0, 1, 2, 3 and up to 9. Now 0 to 9 are 10 digits, so this is an array of 10. So we can display now any digit in the world, or with a counter we can display any counting value in the world. Now we get to our forever loop, write down while 1, and now we will need a counter as well. So we initialize another variable for the counter, write down int counter like this. Now initially the counter value must be 0, so make it 0 in the one time loop, counter equals to 0 whenever the programming starts. Now first of all we display this 0 on the screen. So to display this, you have to take the initial state of the digits. Now whenever it's 1, it means that the digit is off. Now this is our unit digit, that is the D4. I make it 0. Now it's enabled. Now we write on it port B equals to this array display. Copy it, paste it here. Inside it, write whatever you want to display. This counter, we have to display the unit digit of counter at D4. So we write counter. Now mode of 10. Now why we are using this mode of 10? Because let me show you. Let me zoom out. See that guys, this is digit 1, digit 2, digit 3 and digit 4. You can see that here is our digit 4. Whenever it will go to 0 to 9, then the control has to be transferred to the 10th digit. When you use the mode symbol, this mode or percentage symbol basically means that you are taking a remainder. Remainder will be taken and rest of the value will be transferred to the next digit. Similarly, when the 10th digit reaches the 100 value, then again like it reaches the 99, now it is at the 100, then again the control has to be transferred. So similarly, that's why you will use the remainder symbol here to transfer the control to the next digit. Now guys, this is our unit digit of whatever the unit digit of the counters will be displayed at the digit 4. Now we give some delay. Now this delay is important to control the triggering speed, because we are using multiplexing way of displaying the data, and multiplexing means that one by one each digit will be updated at such a speed that our eye will get dodged, that it will think that the digits are constantly on, while in reality it is being done sequentially one by one. So now bring it to the initial state. Again turn off the digit, it was on, now enabled, now it's again disabled. Now we go for the 10th digit, this was the unit digit. For the 10th digit again copy this, paste it. Now disable the D4 unit digit and enable the 10th digit, that is the D3. Now here just divide it by 10 to make it the 10th digit. Now this is the 10th digit of the counter. See, now again disable it, it's disabled. The 10th digit is displayed and the value is disabled. Now we go for the 100 digit. For the 100 digit, now again disable the 10th digit and enable the 100 digit, this digit like this. Now the 100 digit is enabled, divided by 100, counter divided by 100, mode of 10, this will be the 100 digit, and now again it is displayed on the screen. Now first of all, before going for the counter, we give a random value like we display 1, 2, 3 and we check either it is displayed or not. I click on build, check for errors, no error. Now we burn it into the microcontroller. I go to this MikroC for PIC. Go to file, PIC16 programming tool. This is our program. I click on write. Okay, the new code is being written. Let me zoom out and let's go to the hardware. So this is the hardware and the new code is being written. Let's see what happens. Okay, I power it up from the PIC16 programming tool. I click on. See, it is displaying 1, 2, 3. You can see that it is displaying the value 1, 2, 3, but there is a triggering speed. Now we can change this triggering speed. That's why I told you this delay here is very important. Now I make it 5. If I make it 5, it will slow down. It is working fine also, but if you make it 5, it will even go more faster and the display will become more smoother. But this is something you will play with. I will give you this code in the description of this video. I will upload a Google Drive link. You can download it from there and you can play with the code as you like. Now the new code is updated. Let's see what happens this time. So see that we had changed the display speed, so it has made the display more stable. Now it is again doing the same. It is blinking, but at such a high speed that our eye and the camera's eye think that it is constantly being displayed. So now let's continue with the programming. Now let's make a counter. Now initially the counter must be 0 and here we add a line called counter equal to counter plus 1. Now this means that counter is always incremented by 1 whenever the loop repeats, and now in the end we add counter if greater than 999. If it exceeds the 999 value, then write if. What should happen? What should happen is that counter will become 0 again. It will come back to the initial state and it will start all over again. See, if counter exceeds 999 value, that is, it goes to the 1000 digit, then it will repeat because maximum digit we support is 999. So let's build this code. At this time I am not giving any delay, so counter will be very fast. We might not be able to see what is happening. Then we give some delays. I click on write. Let's get to the hardware and see what happens. Let me zoom out. See, the new code is being updated, now we had added a counter that it will increment by 1 with every repetition of the loop. Now see that you can see the counter is working. Let it go up. Let it reach the 999. See that after 999 it starts all over again. See, it is working very smoothly. Now guys, you can play with this code, you can change the values, you can increase the speed, like you can make it 5, that it will increment by 5 with every loop. You can add delays here to slow it down, etc. So there is a lot of things you can do with this code. This code will be in the description of this video. I will upload a Google Drive link. You can download it from there. All the MikroC for PIC files will be there, including the hex file. So you will have no problem with that. So guys, this is it. I hope you guys learned something from this video. Thank you very much for your time. And if you have any questions or queries, you can ask in the comment, and have a nice day.